Hello everyone, myself K. Mohammad Farid, AML branch, third year. Here I am going to present my assignment 1, which is evaluating classification matrix, and the course is Advanced Machine Learning, guided by Akshata AMS, Assistant Professor of AML, GM University. Introduction. In machine learning, evaluating a classifier model is very important because it helps us to understand how well our model predicts unseen data. Simply relying on accuracy is not always enough, especially when the data is imbalanced. That's why we use other matrices like precision, recall, F1 score, and ROC-AUC for more complete understanding. In this project, our goal is to compare logistic regression and random forest classifier using these evaluation matrices. We used here breast cancer dataset from Scikit-learn, which helps predict whether a tumor is malignant or benign. Next is data selection and preparation. For this project, we here we used breast cancer dataset, which is binary classification dataset. It consists of 30 features, all describing the characteristics of tumor like size, texture, smoothness, and radius. The label are 0 for beginning and 1 for malignant tumors. The dataset preparation set includes data cleaning and normalization to remove noise and scale the features, splitting the data into 80% training data and 20% of test data. The main goal of these steps was to prepare clean normalization data so the both models, logistic regression and random forest, could be trained and compared fairly. Next is model training. We trained two models for this experiment, logistic regression and random forest classifier. Logistic regression is a simple linear model that is easy to interrupt and work well for small and linear separatable dataset. On the other hand, the random forest classifier is an ensemble model that combines multiple decision trees. Each tree makes prediction and the forest takes the majority votes. This model reduces overfitting, handles nonlinear data better than logistic regression. After training both models, we evaluate them using several parameters, means using several performance matrices. Next is evaluation matrix. Here we evaluate our model. We use important matrices like confusion matrix, precision, recall, F1 score, and ROC-AUC score for accuracy. Each of them give a different view of model performance. Precision: tell us how many of the positive prediction were actually correct. Recall: measure how many of the actual positive cases are detected. F1 score: combine precision and recall into a single balanced value. ROC and AUC show how well the model separate the two classes overall. Together them matrices give a much better picture than accuracy alone, especially for imbalanced dataset. Next is discussion and conclusion. After evaluating both models, we found that random forest generally perform better because it handles nonlinear patterns and reduces overfitting. We also used a technique called oversampling to balance the dataset. Oversampling creates synthetic sample of the minority class, helps the model detect positive cases more accurately. This shows why matrix belongs to accuracy are more important. Accuracy can look good even if the model fails to identify rare cases, but precision, F1 score, and ROC-AUC gives more realistic view of how well the model is performing. Conclusion: understanding and using multiple evaluation metrics help us to build a strong, more reliable machine learning model. In real-world application like disease prediction, fraud detection, or spam filtering, using matrices ensure the model perform well on both common and rare cases. Thank you.